right, looking at number 1. One thing that we can identify here is that there is something that is shared. And there are no angles here. It's not bisecting. We can't tell it's bisecting. But we can tell that there is something being shared. They're sharing this side. And yes, Marco, this is side, side, side because I have 3 sides on here. Okay, so they're side, side, side. Number 2, looking at this one. Okay, let me just let you know. Some of you said this was hypotenuse leg, but let's check it. There are 3 main criteria that hypotenuse leg has to have. Okay, if you were here yesterday, you should know it. It was very wordy, but I'm going to tell you right now. For it to be hypotenuse leg, it has to have 1 hypotenuse. Obviously, it has a hypotenuse. It has to have at least 1 leg identified. Remember, all of these have to be matching. And it also, most important thing, has to be a right triangle. Okay? So looking at these.
What's a leg? What do you mean?
Okay, so on my triangle, here's a right triangle. These 2 right here, I'll change the color. These 2 sides are considered my legs. And what is opposite of my right is considered my hypotenuse.
So, what do you mean it has to have 1 leg?
So it has to have 1 leg that's identified. Like your congruency marks, it has to show you that there's 1 leg.
Oh, okay.
So looking at this, your hypotenuse has to be what's opposite of your right angle. So looking at it, this line right here that's in green, I'm marking it as my hypotenuse. Are they congruent? No, I see you guys shaking your heads. No. So right off the bat, this is not going to be hypotenuse leg. Is it side, side, side? No, because they're not showing me a 3rd side. So this one's going to be none. All right, looking at number 3. What other information do I know here? What else can I mark? Where can I put another congruency mark? Can I put another congruency mark? Yes or no? Where would I put it?
Other 2 sides.
Which 2 sides?
The left and the right side.
The left and the right side. Let me label this. A, B, C, D. What is shared? Where can I put another congruency mark? Well, I don't know if it's bisecting, but you are right. It is that AC line. This is being shared, so I can make 2 congruency marks. So it is a right triangle, so let's see if it's HL, because I know it's not side, side, side. There's only 2 sides that's given. So is my hypotenuse labeled? Are my hypotenuse congruent?
Yes.
Yes.
Yes, so hypotenuse, which is right here, I'm good. Are they showing me at least 1 leg?
Yes.
Yes. Are they congruent?
Yes.
Yes. And then is there a right triangle? Are they right angles?
Yes.
Yes. So what would this triangle be considered?
HL.
This would be, thank you, HL. Okay, this is hypotenuse leg congruency theorem. Okay, so do we understand the criteria that you have to have for a hypotenuse leg? You have to have those 3 things.
It is so hot.
What are the 3 things?
It is like really hot. It's so
I know,
hot in here.
guys. Say one more time.
How is the second one none?
Because of look at what's congruent. So they do have a leg that's congruent, but this is saying that this hypotenuse is congruent to this, but it's not.
Wait.
Okay, because they're not,
5.6.
it's not hypotenuse.
Is this not 5.6?
And keep in mind, if I were to say, okay, looking at it, this is side angle side. Is this one side angle side? No. Okay. So they're not congruent at all. All right. We are covering 5, 6. And we're covering angle side angle and angle angle side. All right, looking at this one, angle side angle, congruency postulates. If, you're going to have to write it a little small. If two angles, I'm going to shorten it, and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So I'm going to show you what that means because that sounds a little confusing. You have two triangles. What it's saying is you have an angle, which is right here. Let me use a highlighter. And an angle with a side that's included in the middle. That's basically what it means. So this is a angle, side, angle triangle. Okay, if I wanted to write a congruency statement, I could write it as triangle ACB is congruent to triangle. How would I write my other congruency statement? ACB is congruent to what? ACB, good, DFE. Okay, you have two angles and an included side. Your side is included, that means it's in the middle. All right, they're congruent using angle, side, angle. So just showing you where that is. Here's my angle, here's my side, here's my angle, here's my angle, here's my side, here's my angle. So it's angle, side, angle. That's how they're congruent. All right. All right, angle, angle, side. Okay, so again, still following the same pattern. For this one, if two angles, we're still dealing with two angles, and the non-including side. So non-including means it's not included in the middle. So if two angles and the non-including side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the triangles are congruent. Keep in mind, here it says corresponding, meaning it has to be in the same position.
What do you mean?
So if I were to say, instead of my mark being on this side, if it was on this side, over here on the other side, are they corresponding? So you see, you have to kind of look for patterns, because when I'm looking at this, here's one congruency mark and two congruency marks. If my congruency mark was on the side with 1, this one's on the side with 2, so they're not corresponding. So it has to be like it's matching. If it's on the side with 2 and none, then it has to stay on the side with 2 and none. Okay, so it's definitely like a matching game. So highlighting, I have G and J. These are my angle, angle, and then I have my side. Same thing, angle, angle, and then I have my side. So keyword here is corresponding. Corresponding, it has to be on that corresponding side. So if I were to write a congruency statement for this one, I have triangle H HJG is congruent to what? Triangle HJG is congruent to triangle, who could tell me what the triangle would be? Good. LMK. Perfect. And this is angle, angle, side. Angle, angle, and then I have my side.
Wait, what was the one above it?
Like the previous one that I went over?
Yeah.
That was angle, side, angle. So your side was included, it was in the middle. That one was right here. But this one is when the side is on the outside. It's not included in the middle. Okay. All right, this is the summary of what we have gone over. We did side, angle, side before we left for winter break. We did side, 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 and hypotenuse, leg. Hypotenuse, leg, key thing here is it's only right triangles. If you have something else that's not a right triangle, you can't do it. Okay, we're doing angle, side, angle, and angle, angle, side today. So these are the two that we worked on. Okay, so please notice where that side is. One's on the inside and one's on the outside. All right, looking at these examples. Can the triangles be proven congruent with the information given in the diagram? If so, state the theorem you would use. So we're going to do A together, then I'm going to have you try and do some on your own. So looking at this image, is there any information that I know on top of what they're giving me?
The vertical angles.
Which one?
The vertical angles.
The vertical angle is perfect. I know that this angle is congruent to this angle over here. My vertical angles. My vertical angles are congruent. So looking at this, even though it's a right angle is still an angle. Don't just get rid of it and say, oh, there's only one angle. There's actually two angles. I have angle H is congruent to angle E. I have angle HGD, because remember, I can't just put angle G and angle G. Angle HGD is congruent to EGF, and then I have my sides. DG is congruent to FG. All right, looking at the image, which congruency theorem did I use? Looking at my image, which congruency theorem is this? All right, HL. Remember, I have to have two sides for it to be HL. They're only giving me one. So this is not HL. This is going to be angle, angle, side. Yes.
Oh.
Angle, angle, side.
I don't get it.
All right, looking at it, I have my angle here, and my side. Angle, angle, side. All right, you guys right now are going to do B and C. I'm going to give you a couple minutes to work on it. All right, I'm going to go over these. So looking at B, what else do we know here? What else can I identify?
The side in the middle.
Good. This side in the middle, they're sharing that side, so I'm going to make two congruency marks. Is there anything else?
They also share an angle.
No. I can't say they share an angle because they're not telling me it's bisecting. Okay, so for all we know, the angle measurements could be the same. So this is it. This is all I have. Is this considered congruent triangles?
So is it just none?
It would be none. I cannot tell that these are congruent triangles at all. All right, looking at the last one, what else do I know here? What other information can I identify? Is there anything else that I can identify here? Their shared side. Okay, good. So this is they're sharing the side. They're right next to each other. What kind of triangle is this? Is this a congruent triangle?
Angle, side, angle.
Perfect. Angle, side, angle. Any questions on these three?
Miss Chung, for the whole day, it hasn't been letting me access my ability.
All right. Any questions on these three? No? All right. Looking at these three that's on here, go ahead and try and do these three by yourself, and then we're going to check them. All right, I'm going to go over these. So looking at A, remember we are dealing with triangles. So the triangles you should have used is this one right here and this one right here in red. All right, things that they're giving you. One thing that they're giving you is these angles on the side. 1, 2. And my side measurements. What else do I know? What else can I make? What other marks can I make here? Vertical angles. 1, 2. Looking at these, what kind of triangle is this?
I saw a right triangle.
It is not a right triangle.
Isosceles, correct?
They're not showing me.
Angle, side.
What?
Angle,
This is an angle side congruency theorem. I have two angles and a corresponding side.
Where's the second angle?
We made the second angle.
I see it.
Okay, we have one here, one here, one here, and one here. We drew the vertical angles because we know that these are vertical angles.
What is it?
Angle, side. All right, looking at B, is there any other information that we need to identify here? No. Is this a congruency, a triangle congruency? Is there a theorem for this one? There is no angle. So for this one, it would be none. You would need a side to make something. Yeah. All right, and then the last one, C, what other information do I know here? What else can I make? B was none because there's no sides, and I can't state it as...
There's like a million sides.
No, there's no sides marked. All right, C.
What's the last thing we're doing?
All right, looking at C, what else do we know?
Like the shared thing in the middle.
The shared thing in the middle, yes, this is shared. So what kind of triangle is this? What theorem am I using?
The
Angle, side,
angle.
angle. Good.
I'm confused. Where's the other triangle?
Okay, where are the triangles? You guys have to be able to identify these. I know it's a little hard because it's blurry, but I'll make the lines a little thicker so you can see it.
And where's the second angle?
Miss Chung, that's confusing though, because there's so many angles.
Well, you guys will have images like this on your
wait,
quiz.
Two lines. If there's like two lines on the angles, does that mean there's two? It's like
Okay, so it's showing you that they're congruent. So this one right here with the two sides is congruent with the two sides.
So where's the second angle?
This with the one side is congruent with the one side. That's what I'm telling you guys. I keep telling you it's like you're matching. Okay, two sides go with two sides, one side goes with one. So if you want, I'll change the color. Here's the yellow one and here's the yellow one. Okay, it's really like a matching game. You're just matching the sides that go with each other. All right, looking at these examples. Please, for everybody, if you're not drawing on your paper, if you're not drawing on your iPad, you're just looking at it, you're going to eventually mess up somewhere. So when you're looking at number 1, they're telling you that this angle is congruent to this angle. 150 is the same as 150. And then 15 is the same as 15. I'm marking it with one congruency mark because it's a different measure than the congruency mark with 2. Does that make sense? Does everybody understand that? You're representing them using different congruency marks because they're different measures. So looking at number 1, what kind of postulate?
Angle.
Perfect. Wow, I didn't even get to finish what I was saying. Angle, side, angle. Perfect. All right, number 2. This is a 90-degree angle, so I'm drawing that 90-degree symbol. Looking at this one, what kind of congruency theorem is it?
Side, angle, side.
It is not side, angle, side. It is not none.
Is it side, side, side?
All right, remember, whenever you guys see a right angle, think of hypotenuse leg, because that's the only one with a right angle. Once you think hypotenuse leg, think of the things it has to have. Does it have a hypotenuse that's congruent? So yes, here is my hypotenuse. And then does it have a leg that's congruent? Yes, here is my leg. And is it right triangles? Yes, so it is hypotenuse leg. Okay, it has to have those three things. You have to have those three things. And then looking at number 3, this can be different ones depending on what you found. So looking at this one, what else do we know? Okay, the vertical angles are congruent. Perfect. So I could draw this here. And then what kind of triangle would this be? Side, angle, side. But also, you could have said, oh, but there's a shared side. And call it side, side, side. So depending on what it's giving you, you can figure out what it is. Okay? It could be either one depending on what you found. Any questions on this? All right, looking at this example with a proof, we are going to first draw our T-chart. So we have our statements and our reasons. Statements, reasons, and what is my reason number 1? What's my statement? Good, it's always going to be given. So that's my reason. Not on the quiz, but definitely on the test.
You said we were gonna have one.
I'll double check. I'll let you guys know tomorrow if there will be a proof on the quiz, but definitely there will be one on the test. I have JL, line JL bisects. What does it mean to bisect?
To cut in half.
Perfect. Bisects angle KLM, and angle K is congruent to angle M. Okay, so that's the first thing that should be written on here. All right, next. All right, looking at the image, bisect, we said cuts in half. So if this line right here, we said this line, JL bisects it, what does it do to my angles? So what I mean by that is if this entire angle right here is 60 degrees, when it bisects it, what changes?
It's 30 degrees now.
Each angle would be 30 degrees. So for my next statement, I know, because remember we're trying to prove the triangle to be congruent. I know that angle, I'm going to step 2. I know that angle KLJ is going to be congruent to angle MLJ. Why? Because that is the definition of angle bisector. Okay, because we know the definition of angle bisector, we know that the angles are going to be congruent. So this angle will be congruent to this angle. Okay, so they gave us one angle. We found another angle, and then what else do we know? What else do I know on this image, on this diagram? What else do I know here? Good, perfect. Not JKL, but a specific line. If they're already giving us that K is congruent to M, I don't have to state it because it's already given. They already showed it to me. But there's something else that I know. So looking at this image, what else do we know is congruent?
KM.
No, KM, yes, but it was given to us, so we do know. Good. JL is congruent to JL. Okay, JL is congruent to JL. Remember, I'm trying to prove that the triangle is congruent. How can I do that? I can use the congruency theorems. I can use angle, side, angle. I can use angle, angle, side. I can use HL. I can use side, side, side. I could use any one of those to prove that this is congruent. But they already gave me an angle. They're connected by a side. And I proved that the angles L are congruent. So looking at angle 3, what's my reasoning for knowing, not angle 3, but statement 3?
It was like reflexive. Right?
Perfect. It's reflexive. And I stated all three things. They gave me what was given. They gave me what was given, which is right here. These two are congruent because of definition of bisector. And this line is also congruent because it's reflexive. So now I can give my answer, and I can say step 4, triangle JKL is congruent to triangle JML because of what? Please do not put, that's the answer. Prove. Don't put that. That's not your answer. That's never going to be your answer. Looking at my triangles, what theorem did I use to prove that this is congruent? Angle, angle, side. Okay, so showing where that is, here's my angle, here's my angle, here's my side, here's my angle, here's my angle, here's my side for each triangle. So this is the proof for this question. Angle, angle, side. Any questions on this one? Yeah. Oh, thank you. I wrote that wrong. It should be JL and JL. Thank you for letting me know. This should also be JL. Because it's specifically talking about the line. So I'll highlight it in purple. This line right here.
Wait, what'd you change?
I accidentally wrote right here JK, but it should be JL. You have it, yeah, that was just me. Questions on this one? All right, 2 more slides. All right, it says, can the triangle be proven congruent with the information given in the diagram? If so, state the theorem you would use. So looking at this diagram, looking at the image, a couple things we know. We have parallel lines and we have a transversal. So we have to go back to what we learned before we went on break. Here's a parallel line, God bless you. Here's a parallel line. Here is my transversal. So looking at this, I'm able to find angles that are congruent. Can someone tell me which angles are congruent? What would I use to find that the angles would be congruent? Which angles would be congruent here?
B1 and 3.
Perfect. 1 and 3 are congruent. So angle 1 is congruent to angle 3. And what did you use to find that they're congruent? What are those angles called?
All interior.
Alt interior. Perfect. What else is congruent?
2 and 4.
2 and 4 is also congruent. And that's the same thing. We have to remember alternate interior. And that is not enough information, but there's something else that I can see on here. What else is congruent? X, Y is congruent to WZ. They're not congruent. I cannot say that. They're parallel, but I can't tell that they're congruent. They're not telling me that they're the same measure. So I can't say X, Y, and WZ. WY is congruent to WY. Why are they congruent? Looking at it, they're sharing the side. So like the previous question, it's reflexive. So looking at it, WY, let me finish writing this. WY is congruent to WY. How do I know they're congruent? Congruent because they're sharing it. So if we're looking here, I have one triangle and another triangle, and they're both sharing the bottom. They're both sharing their base. So this line right here is being shared between both triangles. Okay, and looking at it, no, I'm zooming in and out. Hopefully nobody's getting dizzy. What theorem am I using for this?
You can use angle side.
Perfect. This is going to be angle, side angle. Angle, side angle would be my congruency theorem for this diagram. So for homework, if you're wondering, oh, how do I show my work? Look right here. I told you what was congruent, or I showed you what was congruent. So there's two ways for showing your work. All right, and the last one, example number 5, are these triangles congruent? Explain why or why not. So looking at it, is there any other information we can find?
Vertical angles.
Perfect, I have my vertical angles right here. And if it's a right angle, if I see that these are right triangles, I always think of HL first, but let's see if it meets the HL requirement. Is it showing me a congruent leg?
Yes.
Yes. Is it showing me they're right triangles?
Yes.
Is it showing me a congruent hypotenuse?
Yes.
No.
No.
Okay. There's no congruent hypotenuse here. Okay. So it cannot be HL, but it could be something else. Keep in mind when they're right angles, that's still considered an angle. It's still considered an angle. So right now I have angle A is congruent to angle D. AC is congruent to CD. And then we did our vertical angles. ACB, angle ACB, is congruent to angle DCE. So knowing those three things, looking at my image, are these triangles congruent?
Yeah.
Yes, using what?
Angle, side.
Not angle, angle, side.
Angle, side.
Perfect. Angle, side, angle. All right. Any questions on these? All right, you guys are having your quiz on Tuesday. Please don't forget.